In this, we'll see the monoalphabetic substitution cipher. Actually, this monoalphabetic substitution cipher has various variants. In the material that I have provided, that is classical encryption techniques, so a frequency-based allocation was there. So basically, this monoalphabetic substitution cipher is just like the Caesar cipher only, but with some modifications. Actually, the first one is the first way of implementation of monoalphabetic cipher, substitution cipher is fixing a particular cipher character for the plain character. So you can fix whatever you want. That is one thing. That is first one. That is the first way of doing it. It is just like Caesar cipher, in which what you are having, that is for every plain character, increment by 3 characters and add it as the cipher text. So here 3 characters is the norm that is going to be formed in the Caesar cipher. But in case of monoalphabetic cipher, that is up to you what you want to increment. Whether you want to increment 3 or 5, or for every character you want to increment, that is up to you. But there should not be any duplicacy. There should not be any duplicacy in the cipher text. That means once the character has been available in the cipher, then the same character should not be used. This is what the condition in the monoalphabetic cipher. So you may implement this condition with the simple Caesar cipher and by extending that particular Caesar cipher concept. That is first thing. So here, this is the material that I have downloaded from the internet. It looks very simple. Here, a monoalphabetic substitution is a cipher in which each occurrence of the plain text symbol is replaced by a corresponding cipher text symbol to generate cipher text. The key of such a cipher is a table of the correspondence of a function from which the correspondence is computed. So here, an FN cipher E of x is equal to ax plus b mod 26 is an example of a monoalphabetic substitution cipher. So here x is the plain text. So ax plus b, here you can add whatever the length you want. In case of Caesar cipher, you may add 3, and here you may add whatever you want. So that is what the FN cipher that you will get out of this. But as per the condition of the monoalphabetic substitution cipher, there should not be any duplicacy. So sometimes it may generate duplicacy. Okay, and there are other 2 ways of generating the monoalphabetic substitution. The first one is alphabetic mixing via a keyword. So as we have seen in the program, that what we have given here is in the question 2, a client server uses the monoalphabetic cipher to transfer the information among them if the key graph is built from the following paragraph. So here this was given as the keyword. So as we have seen here, the alphabetic mixing via a keyword. So this was given as the key graph or keywords. So here a lengthy keyword was given, but our plain text is very small. It is in small in length. That is, I am a JIT student and I am practicing information security. It is very here the number of characters are very small compared to the keyword. So hence we'll see some alternative for this. First, we'll discuss how it will be implemented with the help of the keyword. Alphabet mixing via a keyword. A keyword or a key phrase, or we can say in our sense here it is a key graph, can be used to mix the letters to generate the cipher alphabet. For example, if the keyword is Andrew Dixon White, then the cipher alphabet is given by like this. Now, you are considering the plain text A, B, C, D, E, F, G, H up to Z. Now, whatever the keyword is there, that you place like this as it is. A, N, A is under A, B, N is under B, and D is under C, R is under D, E is under E, and W is under F. Now, in the keyword, this one is over. Now, D has to be placed, but D is already occurred. So, what is the condition of the monoalphabetic cipher formation? There should not be any repetition in the cipher. So, D is already appeared under C. So, you should not use this D. Okay, you should not use this D. So, you can skip this D, and check for the next character I. So I is there. So I has not been appeared before. So under G, we'll place I. Okay. Now C. Did C occurred previously? No. C. K is also not occurred. S is also not occurred. O is also not occurred. But N occurred because N is under B. Now W, did W occurred? Yes, W occurred below F. So W can be skipped. H was not occurred. I was occurred, and T not occurred. E was occurred. So whenever we remove the already occurred things, so then the keyword was over. Once the keyword was over, then then let will make no let will make from let will make the repetition with the help of the plain text again, the repetition of the plain text, so that we have to check whether the same characters have been appeared here or not, because we want to repeat with A, but A is already appeared, B was not appeared. So B, E, F, G, H was appeared, F, G, J, L, M. So whatever the things were not appeared, that was written according to the alphabetical order. So that means this keyword has to be written here, and the condition for the monoalphabetic cipher is in the cipher there should not be any duplicacy. So while doing this, we observed total 5 collisions. That means this keyword, whenever you write this keyword here around 5 collisions were occurred. So do you think this is a problem? There are 5 collisions. Obviously, it is a problem because if the plain text length is small and the keyword length is small, if the plain text length is large and the keyword length is small, obviously there will be a number of collisions. So perhaps a better keyword. So we'll choose some better keyword for this is EZRACORNELL. So whenever we place here, we didn't find any collision. Straight away, this particular keyword was fitted here. So that means here the better keyword we are going to search for and we are going to place here. Okay. So note that neither of these substitutions are generated by the FN cipher. So this alphabet mixing via keyword, okay, whatever the procedure we have discussed here was not defined, was not generated with the help of this particular formula, that is FN cipher. So this is the way we used to do. So that is the reason under this particular, I am JIT student and I am practicing information security. Now what you are supposed to do is you are supposed to label the keywords, label the characters from A to Z. Under the A to Z, you have to use this paragraph as the keyword. So under A, you are supposed to place T. Under B, you have to place H. Under C, you have to place E. Under S, under D, you are supposed to place S. And under E, already E was appeared, so E can be skipped. Okay. Next, A can be placed, R can be placed, E is already appeared, E can be skipped. So like that, you are supposed to arrange this this particular paragraph under the A, B, C, D, E up to Z. So to know how many that is how many characters was frequently occurred, or what is the frequency of the characters. So a frequency distribution table has been built over here, so that based on this they can go for formulation of the cipher text. So that is what the idea was given. That is what the basic idea with which this particular frequency table was provided in the classical encryption technique material. I hope by this time you got this monoalphabetic cipher distribution with the help of the first method, that is alphabetic mixing via keyword. And here another method has been provided, alphabetic mixing via columnar transposition. The letter from the keyword from the heading of the column and the remaining letters for the alphabet fill in order in the row below. Mixing is achieved by the transcribing the columns. If the keyword is cornel, then write like this: cornel. Then just write A B C D E F G H I J K L. I J K L. L is already appeared, so don't write this L here. Okay, don't write L. So skip this L. M. N is already appeared, so skip N. O is already appeared, so skip O. P is not appeared, so P. Q. R already appeared here, so skip it. S. T. U. V. W. X, and here Y. Z. Now this is the matrix kind of arrangement was made without any duplicates. Now this particular matrix kind of thing will be placed as the ciphertext under the plain text via transposition. So here the first column will be placed like this: C A I S Y. Now O B J T Z R. Okay, this is the next third column. So Z, R D K U. So like that, N F M B E. Like that, all the columns were arranged here. So here total 1, 2, 3, 4. Okay, 4 into 6, 24 plus 2, 26 characters, and here 26 characters was appeared here. So here there is no duplicacy because already we have formed the matrix with without duplicates. So hence the ciphertext will be having the duplicate, will not be having the things. So for our problem, this is the best solution we can make. For our problem, this is the best solution we can make. That is, the keyword is like this. So the keyword is like this. So T H E S A R E. So what you can do is you can make a matrix. You can make a matrix. So T H E S. Okay. A is not appeared. E is already appeared. So A is not appeared. A. R is not appeared. R. So here 6 characters are over. Next, E is already appeared. T is already appeared. H is already appeared. E is already appeared. S also appeared. P was not appeared. P. Next, I was not appeared. I. R appeared. I was not appeared. I is already appeared. T is appeared. U is not appeared. Okay. So U is not appeared. So you include U. A is appeared. L is not appeared. L. E is appeared. X is not appeared. E is appeared. R appeared. Okay. C is not appeared. So here P I U X L X C. So this is the 6 characters over. Now another 6 characters we need to pick. So up to here we got, that is C. I is appeared. S appeared. E appeared. S appeared. O is not appeared. O. Okay. And F not appeared. S appeared. T appeared. Full stop not appeared. Okay. I is appeared, and G. Okay, G not appeared, and N is also not appeared, and A appeared. T appeared. I appeared. U appeared. S also appeared. O appeared. F appeared. L appeared. O appeared. Y is not appeared. Okay. So 18 characters are over. Now, like that, you are supposed to complete it, this matrix. Okay. And under the plain text like this, up to A to Z, you just substitute this T H E S A R. So under this, you just arrange So T H THESAR. So THESAR. So like that, you arrange the cipher text, what you have observed via this matrix. Here I have mentioned in a row fashion. You can also mention in the column fashion TPO HIF like this. So you can also mention like TPO. So TPO HIF. So like that, whatever the columns are there, you can mention the columns over here, so that you will get the cipher conversion or cipher text related to it. So this particular key should be shared with the client also, so that client will also look into this particular matrix or table and will go for converting from the cipher text to the plain text. So if you look at, for instance, far above this particular text can be replaced as F will be replaced with O, and A will be replaced with C, like that O C V C A N W Y I C. So this is the cipher text that you will get. And one more thing is, either the alphabet mixing via keyword or alphabet mixing via column transposition. In both of the cases, no, the resultant cipher text is not generated by the FN cipher. That is what the standard formula that we have seen here. Okay, so if you use standard formula, sometimes you may get the collisions, or anyhow, we have mentioned it as mod 26. Sometimes you will not get any collision here. That is up to you to fix what is the value you want to convert. But if you fix a value, it is just like almost like scissor cipher. After several observations, the intruder can come to know what the increment you have made. But with this, you cannot come to know that even the intruder cannot come to know what type of jumbling has been done in formulation of the cipher text. So out of the first method, I will prefer the second method for you to proceed further. So you may implement the second method. It is very easy to implement, and you can work very easy as possible. So this is what about the monoalphabetic cipher.